It's a pleasure to be here today, and I very much enjoyed the conference yesterday. When Duncan was describing NERC's approach to funding for science, it was interesting to hear that he was spending 93% of his funds on fundamental research and 7% of the funds on outreach of that research. I guess myself, was part of an early part of that program in the late 90s. I had a NERC Environment Agency fellowship as putting a marine scientist in with policy analysts to work on climate change and coastal issues, a kind of fish out of water approach. And some of what I'm going to talk about today kind of relates to the experience from that process. And over the last few years, we've been working on how to connect coastal conservation and restoration approaches to developing climate change mitigation frameworks. I'm going to talk about that. It's become known as blue carbon to some degree, but we're focusing here on coastal blue carbon as opposed to oceanic blue carbon. And I'm going to try and highlight some things we've learned that could be translated to the deeper ocean. Now, over the last 10 years or so, there's been a lot of activity related to biological carbon sequestration, how to connect ecosystems to the removal of greenhouse gases from the atmosphere. It started with forests. There's a lot of above-ground biomass, but over time we've realized, well, not all the carbon really is in the above-ground biomass, it's actually in the soils. So people have been working on peatlands for the last 5 years, trying to bring those into climate change frameworks. And what we're doing here is extending both of those frameworks, both those approaches, to nearshore marine ecosystems, including mangroves, including salt marshes, and also going down below the water table to include seagrasses. So we're taking terrestrial approaches using existing frameworks and trying to extend the range of ecosystems that can be included in that. Now, tidal wetlands are interesting because they store carbon pretty effectively. They're wet. They're good for carbon storage. They build up with sea level rise. What you may be able to see from the screens is that the vegetation on the top, what people normally think about in terms of the carbon, is actually a very small pool compared to the amount of carbon that builds up over time, over thousands of years. Now, this is the case all the way for salt marshes, mangroves, and seagrasses. Now, the issue, of course, when we look around the coast, is that we've converted all of these ecosystems to something else. Arable land, settlements, rice fields, shrimp ponds. Here's an example from the UK, which is well documented, Humber Estuary. Over 300 years ago, we converted all these wetlands, freshwater wetlands, tidal wetlands, to arable land, cut down the carbon sequestration of the estuary by 99%, released a lot of CO2 in the process. Now, one of the comments that was made yesterday, I threw in this slide, was that the expansion of agriculture in the tropics is really a function of local subsistence farming. And I want to counter that by saying, no, it's not. What we're seeing in the tropics is a lot of degradation of wetlands. We destroyed ours in Britain 300 years ago. North America did theirs 150 years ago. Then it moved through Thailand, Vietnam. It's now moving through Indonesia and China. And Africa is on the brunt of this. What you can see here is an example from Indonesia. This is work documented by Faiz Rahman, who looked at the blue line is the cumulative amount of mangroves loss, and the red line is the expansion of shrimp farming and export to the US. And what we're seeing is that Europe and the US is subsidizing shrimp farming, which is leading to a lot of degradation in the tropics. And so sustainability policies in those nations could help counter, to some degree, the impacts of this shrimp farming. So there's not just an environmental impact of that, but there's a carbon impact. Now, when you look at the distribution of carbon within these ecosystems, a large portion of it is in the soils. Now, if you only consider the top 1 meter, and in this graph here, the brown represents the carbon held within the top 1 meter of soil, and the green represents the carbon held within the living biomass. So the bottom line is tropical forests, and then we have seagrasses, tidal marshes, and then we separated mangroves into 2 ecosystems, but you can consider the same. And roughly, tropical forests per hectare hold about 1,000 tons of CO2 within that combined pool, half of which is in soils. But seagrasses hold as much as the soils as tropical rainforests. Mangroves and salt marshes, more so. So on a per unit basis, these ecosystems hold a lot more CO2 trapped within them than tropical rainforests. Yet they occupy a much smaller area, and they're being degraded several times faster than tropical rainforests. So there's an opportunity here to try and connect carbon management to conservation of these ecosystems. And what's also important is that the rate at which the loss takes place. Now, here's an example. This is from my new neck of the woods over in California. This is the Sacramento Delta. It used to be a very nice freshwater tidal wetland, around about 180,000 hectares in size. It's now very nice agricultural land. They converted it about 150 years ago. Now, in that time, by diking off those wetlands and draining them, they've released around about a gigaton of CO2, and some of these areas are now more than 20 feet below sea level. The volume that's being created there is 3 billion cubic meters in size, and that's just one wetland. So what we're seeing that this process goes on all the time. Each year we'll lose around about an inch of soil, and it's CO2 evaporating and going directly to the atmosphere. We're releasing in this one wetland alone 5 million tons of CO2 each year. That's equivalent to 1% of California's total GHG emissions if they were to account for it, but it's not within any accounting frameworks right now. And that's just one wetland. Now, interestingly, there's some experiments here to show that for these type of wetlands, you can put it back again. Now, this is quite rare for most coastal ecosystems, but in this case you can. And experimentation over the last 10 years has been building up the soils on some demonstration plots. And here you can see the baseline emissions, 25 tons of CO2 per year. Sequestration rates are around about 30 tons to 40 tons per year, net methane, so that's including the methane within the component. So you're having a net carbon sequestration of over 30 tons per hectare per year, possibly up to 60 tons. Now, for a biological system, this is enormous, but it's only been tested in one location. And one thing I would like to see is this tested in other parts of the world on other reed bed systems, as once existed really in the UK, occurred around Europe and other parts of the world. So there's potential here. Oh. Poltergeist. And that's what the reeds look like in their natural state. So we went to the World Bank and said, well, you know, how common is this kind of emission? And we did a quick scoping study looking at about a dozen estuaries to represent different parts of the world. The green line there is the Sacramento Delta, and we compared it to some other places, look at the accommodation space that's been created, which we derived from satellite imagery. And it's not uncommon to find this. The Po Delta, 1.4 billion tons potentially since that time. The Wash and the Humber together, and the Chinese estuaries, deltas, which have been diked and drained recently. Possibly about 3 gigatons of CO2 have been released over that time frame. That's a significant amount that hasn't really been accounted for. I'll come to the annual rates in a moment. So how do we try and move this forward to try and connect it with policies? We did it in the following way. We produced a document for the World Bank that gave a sense of what these emissions were. Duke University came along and they did an independent look and said, okay, the science of this is pretty sound. They took a broader range of scientists, but they also included the economics and said, well, is this economically viable? And they said the sequestration component would not make an economic instrument at the rates that these ecosystems remove CO2 from the atmosphere, but the emissions rate, the rate that it occurs, is economically significant in many parts of the world, possibly countering shrimp farming, which is a fairly lucrative lifestyle. Then another group came in, funded also by the Linden Trust, and said, well, can we take this and extend it and couple it to existing climate change framework policies? And they said, yes, there are various mechanisms. We can insert it into RED. We could insert it into developing NAMAs, which are coming up. So we have opportunities to extend existing frameworks, which is crucial when you're working with climate change negotiators, that you're not trying to create something new, but extend things they've been working on for a number of years. We published the estimates of emissions last week. Our best estimate right now, with very wide error bars, is that potentially somewhere around about 450 million tons of CO2 being released by degraded coastal ecosystems each year. Now, what's that? That's roughly equivalent to the emissions of the UK. Now, our error bars range from 150 million tons to up to a gigaton of CO2 per year. So the error bars are fairly wide. And that reflects a number of things. One, we don't know the exact extent of these wetlands and how rapidly they're being degraded in parts of the world. It hasn't been mapped very well. And also, we don't understand all the mechanisms of the release of the carbon. If it goes directly to the atmosphere, we can quantify that. But if it erodes away and washes into the nearshore, how much of it's buried, how much of it gets back to the atmosphere, we don't know. So that's expressed as a range there. So there's a need for additional science there. But that is a significant number. Even at the low end is a significant number. So we try to move this forward to connect it to policy. And what we've done is we've built up a climate change blue carbon initiative. It's led by IOC, Conservation International, and the IUCN. We've built 2 working group series, a scientific working group and a policy working group populated by former climate change negotiators, NGOs. And we're taking the science and connecting it to people who have developed policy to help us try and find ways of getting it to climate change negotiators and others so that can use this information. And then they feed it back to the scientists, say, hey, we need this kind of information, can you help us? And so the science group has been publishing a number of papers. We've been in Nature Geoscience for mangroves and seagrasses in the last year. We're also looking to try and extend demonstration projects and research projects, which are now starting to bubble up. And we're hoping to build capacity around the world. We've managed to help establish a blue carbon working group with the US federal agencies. The European Commission is interested. We were at Parliament in January. Indonesia, Costa Rica, Ecuador have established blue carbon working groups, and Australia is looking at it. I would really like to see a UK blue carbon working group developed in the near term and linked into all of this process. Now, what else have we been doing? What we're also trying to do is connect to the carbon market so we can get some early projects in the ground and test whether financing would help in certain situations. We've been working with the Verified Carbon Standards, which is the largest voluntary registry globally. 50% of all voluntary projects go through the VCS. Right now, you cannot run a wetlands project through the VCS, but we've been helping to try and update or refine their standard. So hopefully in October, you will be able to submit methodologies and projects to the VCS for carbon financing. So that'll be a big step. And hopefully that's going to be adopted by the board. It's gone through public review and should be adopted next month. The IPCC are also mobile in this arena right now. They were going to be looking at terrestrial wetlands. They're now including coastal wetlands in their supplement for national greenhouse gas emissions inventory development. Ongoing right now is including coastal wetlands as part of that, both the destruction and the restoration of coastal wetlands and how to account for those within greenhouse gas accounting frameworks. And that hopefully will be done by the end of next year and adopted by the UNFCCC in 2015. So that means we will have national accounts looking at coastal wetlands, which will help drive the restoration process. We'll have financial mechanisms in place to help finance restoration, and hopefully the science community and the policy community coming together to try and help move things forward. So what are the opportunities? Well, we have an opportunity right now. There's a lot of enthusiasm, interest, both between policy people and between funders and researchers to try and move forward on blue carbon, and we should try and capture that and build research programs around this. There's an opportunity also to connect to existing climate change mitigation frameworks at the international level through RED programs, but also potentially at the state level and national level through the development of NAMAs. NAMAs are very flexible. If you can incorporate your own mitigation activities into those NAMAs as a state program. The UK could have its own NAMA for coastal wetlands, for example. And there's also funding coming online for climate readiness activities for adaptation and mitigation. So there may be funding streams of several millions of dollars, hundreds of millions of dollars, which would help connect these things together. What are the challenges? Well, we lack quantification. You know, a lot of science right now is focused on pristine ecosystems. We need some of the science to focus on the degraded ecosystems and help with that quantification. One of the big questions is the fate of remobilized carbon. You know, the fate of carbon when it's released to the atmosphere is very direct, it's very quantifiable. But if a salt marsh erodes, because it has nowhere to migrate to, does that carbon go back to the soils, in which case it doesn't really matter? If it goes to the atmosphere, then it's more significant. We need whole-scale GHG budgets for coastal ecosystems. Now, on the policy side, one of the challenges, and if you're working on oceanic carbon, one of your challenges is the complexity. You've got to simplify it so policy people can understand it. You've got to be able to demonstrate the application of what you're trying to do. One of the big challenges for oceanic systems is property rights. Everything that's being developed right now on the terrestrial side assumes somebody owns that carbon. You've got to be able to assign somebody that's going to have responsibility. Who has responsibility for the oceans? And information overload. These people are working with a lot of different activities and frameworks and policies. If you bring something new, it's like, what do I do with this? You've got to try and provide a way that they can take this in and they can work with it. So as a last slide, what are the priority needs that we've got? We need data collection from the scientific community. From the scientific community, but also the sort of consulting community, we need to develop methodologies for monitoring emissions and emissions reductions and removals. Methodologies, technologies, that kind of thing. We need to be able to assess the specific drivers. What are the causes of the destruction of these ecosystems? And therefore, what can you do to prevent that? We need to develop reference emissions levels for more and one type of ecosystem. And then we need to actually demonstrate the policy application in coastal ecosystems. Show that if you do it, it can actually be done. We need to build those kind of demonstration projects. And with that quick run through, I'll leave it there. Thank you.